Welcome back to the deep dive. So I was sitting in traffic this morning, right? Just staring at my dashboard. And it just hit me.
Oh, yeah.
We are. We're completely obsessed with the upgrade. We want the phone with the better camera, the app with the cleaner interface.
Yeah.
We're trained to think that change always means better.
It's the whole narrative of progress, isn't it? If you're not changing, you're stagnating. That's the mindset.
Exactly. But today, we're going to kind of flip that script completely. We've got some fascinating material here that argues, at least in the world of high-stakes industrial and digital infrastructure, that change is actually the villain.
The villain, I like
It's the chaotic element. It is the one moment in time when everything is most likely to just fall apart.
That is a very, very sharp way to put it. I mean, think about it. When a system is running, whether it's a power plant or a server farm, it's in a state of equilibrium. It's stable.
Right.
The moment you introduce a new variable, a software patch, a new piece of hardware, you're introducing chaos. You are introducing risk.
And that is exactly what we are digging into today. We were looking at a safety training protocol. It was prepared for the ABM project in Uttar Pradesh, India.
Right, from a vendor called BSL, and it's dated January 19, 2026.
Now, before you tune out thinking this is all about, hard hats and concrete, I want to flag something really important.
Please do.
This isn't just heavy industry. The context here, it explicitly covers digital government projects, things like fast pace and e-municipality.
So we're talking about the infrastructure for smart cities.
Yes. This applies to the server room just as much as it does to the construction site.
Absolutely. The principles of safety. They don't care if you're dealing with high-voltage cables or high-speed data lines. Gravity and human error work the same way everywhere.
So our mission today is to figure out how professionals manage the risks of the new. We're going to unpack a concept called management of change, which sounds incredibly boring.
It does.
But is actually a survival mechanism. And later, we're going to find out why the color of a sign on the wall is legally mandated to be a specific shade of blue.
It's a surprisingly deep rabbit hole. Shall we jump in?
Let's do it. So, all right, management of change, MOC. I got to be honest, when I first saw that term in the material, my brain just switched off.
I get that reaction a lot. It sounds like bureaucracy.
It sounds like a meeting that could have been an email. Why do we need some fancy acronym for just changing things?
Well, let me put it this way. MOC is the difference between a routine upgrade and an absolute catastrophe. The material we're looking at, it draws a straight line from unmanaged change to some of the worst disasters in history.
Oh, wow.
They explicitly cite the Bhopal gas tragedy of 1984.
That is a heavy, heavy comparison to make.
It is, but it's necessary. Bhopal is the grim archetype of what happens when systems are modified, maintenance gets changed, safety systems get disabled, all without a rigorous understanding of the consequences. The change wasn't managed.
And the result was thousands of deaths.
Exactly. So when we talk about MOC in this 2026 protocol, we aren't just talking about filling out a form. We're talking about preventing a domino effect.
A domino effect.
Precisely. In a complex system, you can't just change one thing. You upgrade a server, you change the heat load. Change the heat load, you change the cooling requirement.
Right.
Change the cooling, you might overload a power circuit. If that circuit blows, maybe the fire suppression system loses power. MOC is the process of mapping all those dominoes before you even think about pushing the first one.
Okay, let's make this real. The material lays out a 5-step process. So, say I'm an IT manager for this e-municipality project. I want to swap out an old battery backup unit for a new one. Step 1 is identify the change.
Right. And this is where most people fail right away. You might think, oh, I'm just swapping a battery. It's maintenance. No, it's a change. You are introducing a new piece of equipment. Step 1 is just acknowledging you're altering the status quo.
Okay, I've admitted I have a problem. I'm making a change. Step 2 is assess risks. And I feel like this is where I just say, well, it's heavy, so don't drop it.
And that's exactly why accidents happen. The assessment has to be systemic. Sure, it's heavy. But does the new unit actually fit? Does it block airflow to the server above it? Does it need a different voltage? If you install it, does it block the walkway?
You have to play out the entire movie of what could go wrong.
Exactly. Which brings us to step 3, authorize.
This is the part that feels like red tape to me. I'm the manager. Why do I need authorization?
Because you have blind spots. Everyone does. Authorization isn't about permission. It's about peer review. You need an expert maybe the electrical engineer, to look at your plan and say, hey, wait a minute, that new unit is too heavy for that specific floor tile.
Okay, so it's a sanity check.
It's a fatality check.
Fair enough. Step 4, implement with controls. This just sounds like do it carefully.
It's more specific. It means applying the controls you identified back in step 2. If you said, this is heavy, the control is use a mechanical lift. Implementing with controls means you actually follow the safe procedure you designed.
And finally, step 5, document and audit. The paperwork part.
It's the black box part. If something goes wrong 3 months from now, we need to know what was installed, when, and by whom. But you also need to audit it. Did the new battery actually hold a charge during the test?
It's a really rigorous loop, and the text, it applies this specifically to the ABM Project IT hardware, electrical setups. The goal they state is minimal disruption.
Which is absolutely crucial for government services. You can't have the fast-paced toll system go down during rush hour because someone didn't manage a router change correctly.
Now let's pivot a bit.
Yeah.
We've talked about the process. Let's talk about the physical reality. The material has a whole section on equipment safety, and it highlights something called struck by incidents.
Yes, this is consistently one of the top causes of injury in workplaces, globally.
When I hear struck by, I'm picturing like a cartoon anvil falling on someone, or a crane swinging a steel beam. But how does that apply to a digital project? We aren't building skyscrapers.
You would be surprised. In a data center, struck by is a very real threat. Equipment racks are tall, they're unstable until they're bolted down. A server chassis can weigh 80 pounds.
80 pounds.
Yeah. If you're sliding that out at chest height and you lose your grip, that is a struck-by incident that can shatter a kneecap.
Ouch. Okay, point taken. It's not just cranes, it's gravity acting on anything heavy.
Exactly. The material lists a few causes. Outdated equipment is one, like using a wobbly ladder. But a really big one is improper handling. This goes right back to our change theme. New gear often means new handling requirements.
The new gear, old habits problem.
Precisely. If I've spent 5 years installing Model A, which has handles on the side, and then you give me Model B, which has handles on the front, my muscle memory might betray me. I reach for the side, there's nothing there, and boom, down it goes.
And the material mentions compatibility here too, which
Yeah.
I assume means don't plug the 2026 server into the 1990 power strip.
Essentially, yes. But it's also about mechanical compatibility. Does the new mounting bracket actually hold the weight? Mismatched components are a classic cause of failure. You think it's secure, you turn your back, and crash.
And the consequences they list are brutal. Fractures, concussions, but also financial losses and legal penalties.
And that legal aspect is really interesting. If an accident happens because you used incompatible equipment, that's negligence. That stops the project cold. And for a government project like e-municipality, a work stoppage is a political nightmare.
So we've got the change, we've got the heavy equipment. Now let's talk about the environment. There's a section in here called The Invisible Enemy, Obstructions.
I love that title. It's so dramatic.
It is, but they are basically talking about clutter, mess, stuff on the floor. I have to play devil's advocate here. If I'm on a high-speed tech rollout and I leave a few boxes in the hallway, is that really a safety violation?
What? That's the thing.
It feels more like a housekeeping issue, not life or death.
That is such a dangerous assumption. It's just a box. But let's look at what the OSH Code, the Occupational Safety, Health, and Working Conditions Code, actually says. It mandates a workplace free from risks.
Okay, but a box isn't a risk unless I'm just incredibly clumsy.
A box is a trip hazard, and trips and falls are a leading cause of workplace injury. But even more important, think about emergency access. That hallway isn't just a hallway, it's an egress route. If a fire alarm goes off and the room fills with smoke, you can't see the floor.
Right.
That harmless box is now a barrier that could trap people inside a burning building.
Wow. Okay, when you put it that way, the just a box argument falls apart pretty fast.
It does, and there's a psychological piece to it too, sometimes called the broken windows theory. If you allow clutter wires hanging down, trash it signals to everyone that standards are low. If you don't care about the boxes, you probably don't care about the MOC protocols either.
It erodes the whole safety culture. The material even mentions operational delays caused by clutter.
Right. If you have to step over junk to get to a server rack, maintenance takes longer. If you can't find the tool you need because the site's a mess, that's downtime. Clutter is friction.
So how do they manage this invisible enemy?
It's surprisingly low tech. Regular site inspections, just walking the floor with the specific intent of looking for mess. Barriers for overhead obstructions. And of course, signage.
Ah, signage. This is the part I found surprisingly technical. The section's called Decoding the Walls.
It's like a language lesson.
Yeah.
Most of us walk past safety signs every day and they're just wallpaper. But they are a strictly coded communication system.
The material references the OSH Code 2020 and a specific standard, IS 9457, from 2005.
Yes, that's the Indian standard for safety colors and signs. It dictates that you can't just get creative. You can't make a stop sign purple because it matches the office decor.
Let's break down the color code. I think most people know red and maybe yellow.
Okay, red is prohibition or danger. It just screams, stop or fire. It triggers an immediate biological alert response. Yellow is caution. It means be aware. There's a hazard here, maybe a slippery floor or a high-voltage cabinet, but you can proceed if you're careful.
Green seems pretty obvious.
Green is safety. Emergency exits, first aid kits, safe assembly points. Green means go here to survive.
Now, the one that stood out to me was blue. I always think of blue as a calming color, but in safety, it's actually kind of bossy.
It is very bossy. Blue indicates mandatory actions. It's not a warning, it's a command. If you see a blue circle with a picture of a face mask, it's saying, you must wear this. No exceptions.
So red is don't, yellow is watch out, green is safe, and blue is do this.
Exactly. And this standardization is vital because in a panic or a loud server room or a site with multiple languages, you don't want people reading text. You want them to recognize color and shape instantly.
The material also has a really specific placement rule they call the 5-foot rule.
Yes. Signs have to be placed and maintained so they are readable from at least 5 feet away.
I have to challenge this one. 5 feet? That sounds incredibly close. If there's a danger, high voltage sign, I don't want to be 5 feet away before I can read it. Shouldn't it be like 50 feet?
I see your point. But think about the context of an indoor workspace or right on a machine. The rule is a minimum standard for legibility. It means the text and symbols have to be large and clear enough that you don't need to be read on top of it to figure it out.
Okay.
It also implies that you can't block the view of it.
Ah, right. Going back to our clutter discussion.
Exactly. If you stack a bunch of equipment 6 feet in front of a high-voltage sign, you've violated the 5-foot rule because the sign is no longer visible from that distance. You've blinded the safety system.
It's all interconnected, isn't it? The change leads to new equipment. The equipment creates obstruction hazards. The obstructions block the sign.
And the signs are there to prevent the risks from the change. It's a closed loop. If you break any part of that chain, the safety net fails.
So BSL, the vendor, they don't just hope people read the PDF. They have a whole validation process.
Yeah. Which is crucial. You can't just lecture at people. The protocol includes an interactive session, case studies. They actually look at past incidents.
And a simulation.
Yes. They simulate a change like an equipment swap and make the team identify the hazards and pick the right signs. It's practical.
And there's a test. A 10-question quiz, and you need an 80% to pass.
Which is a decent bar. It means you can't just guess your way through. You have to know the difference between a blue sign and a yellow one.
And the part I like best, the follow-up. A site audit in 30 days.
That's the real test. Everyone is safe on training day, but 30 days later, are the boxes back in the hallway? Is that new server rack blocking the sign? The audit keeps the standard alive.
It really reinforces that safety isn't a one-and-done thing. It's a constant discipline.
It is, and specifically, it's a discipline of managing the new.
So let's wrap this up. We've covered a lot of ground, from the philosophy of change all the way to the specific hue of a safety sign.
We have. I guess if I had to summarize, I'd say this. We need to stop looking at safety protocols as just, bureaucratic hurdles. MOC is a tool designed to navigate the most dangerous period of any project, the transition.
And we learned that even in a digital world, physical risks like struck-by incidents and just clutter are major threats. Gravity doesn't care if you're holding a brick or a blade server.
And we learned that a messy site isn't just dangerous, it's likely an illegal one under the OSH Code.
And finally, we decoded the language of the walls. Blue means do it, red means don't.
Simple, universal, and absolutely vital.
I want to leave our listeners with a thought. We started this talking about how much we all love upgrades. We love the new.
We do.
But next time you walk through your office or a construction site or even a shopping mall, look at the signs. Don't just ignore them. Look at a caution sign and ask yourself, what happened here?
That's a powerful question.
Someone, somewhere, identified a change that created a risk. And that sign is the scar tissue. It's the proof that the risk was managed. So respect the sign. It's there because someone was thinking about your safety before you even walked into the room.
That is the essence of it. Safety is the presence of preparation.
Well said. That's it for this deep dive into the hidden world of safety and change. Thanks for listening, and stay safe out there.